we're going to cover some revision of our previous sessions on the circular economy and net zero before introducing the life cycle analysis. Today's content is underpinned by our online training courses, which are free of charge to Scottish SMEs. And for those of you that don't know me, I'm Greg Cranston and I work in the Manufacturing Skills Academy, one of the core business units here at NMIS, and I'm going to give you a quick introduction before I hand you over to Lee and David, who will deliver the main body of today's session. Before we get started, I'd just like to cover off some housekeeping. The webinar is being recorded, and if you don't consent to being recorded, please keep your camera and microphone off for the duration of the workshop. You're still welcome to submit your questions via the chat bar, which won't be recorded. To avoid any background noise, your microphones and your cameras will be turned off during our presentations, and any questions that you have, add them into the chat tool, and there'll be time allocated at the end of the session for some question and answer. So as I mentioned, today's webinar is the third in our Manufacturing a Greener Future series. The previous sessions covered an introduction to the circular economy and an introduction to net zero. Lee Patterson and Dr. David Butler from the University of Strathclyde, who are delivering today's webinar, also developed the training courses that we have available through our learning platform. David also leads the Low Carbon Challenge Fund Extend project. And in today's session, we're going to introduce the concept of life cycle analysis and how this tool can be used to determine an organisation's environmental impact across the different stages of their product or process life cycle. We'll take a look at some different LCA software options, and we'll review a case study to show the step-by-step process. These sessions are designed to give you some knowledge to make informed decisions about how your business can navigate the transition to net zero and a more sustainable future. So before we dive into the main session, I wanted to give you a quick overview of NMIS and what we're here to do. Hopefully everyone joining us today is familiar with NMIS and the support that we offer the manufacturing community, but just in case anyone isn't familiar, I'll give a quick overview of NMIS and the Manufacturing Skills Academy before we start our main session. So basically, we're a national asset intended to support and strengthen the manufacturing community across Scotland and the UK. We work across all parts of the manufacturing sector and the supply chain with companies and academic institutions across the country. The NMIS Group is a group of specialist technology centres, including the Advanced Form and Research Centre, the Lightweight Manufacturing Centre and the Manufacturing Skills Academy. You can see our core business units there on the screen. We're due to move into our new premises near Glasgow Airport later this year, where we're finally bringing all these centres together under one roof. We can help manufacturers across a wide range of areas, from skills development to prototyping or process improvements. We've got access to state-of-the-art equipment and expertise to help support businesses from small to large. And as I mentioned earlier, I work in the Manufacturing Skills Academy, so I'll focus on what we offer for another couple of minutes. So the Skills Academy is here to help companies with their current and future skills needs. Our two current funded programmes give a good picture of the support that we offer. So our first programme is designed primarily to support individuals. This is the National Transition Training Fund and is part of the Scottish Government's COVID response package and helps support individuals who are at risk of unemployment or finding it difficult to find work. There are a range of funded placement opportunities of up to 6 months, underpinned by a range of short courses to help the candidates upscale and rescale. Our second programme is the Advancing Manufacturing Challenge Fund. It's funded by Scottish Government and the European Regional Development Fund, and this project's focused on supporting Scottish SMEs. We're building a range of online content in digital manufacturing and leadership skills to help SMEs upscale and prepare for their digital journey. We've now got a portfolio of more than 40 online courses delivered via our learning management system, and these courses are free of charge for Scottish SMEs. We also offer some more bespoke services where we can provide some one-to-one support. So in addition to our courses and our case studies, you can see some examples of the more tailored support that we offer. We offer some one-to-one consultation, so come and talk to us about your plans or your pain points and find out how we can support you. We've got a range of training through both public or private courses, and now that COVID restrictions are lifting, we can deliver this training face-to-face or online. We can run a number of consultancy-style workshops and a range of digital manufacturing, leadership, sustainability and advanced manufacturing topics, and we can develop individualised learning pathways with access to our learning management system. We can facilitate graduate placements with your business, and depending on availability of funding, these can be fully funded. And we also run an engineering doctorate programme here in the MSA. So our online learning platform offers our learners the flexibility to access our courses 24/7 and is optimized for mobile devices. We're focused on making it an engaging experience with lots of interaction from the learner. And our courses include various forms of media to support the learning and also include short quizzes and knowledge checks. On completion of the courses, our learners will be issued with a completion certificate to log against their CPD obligations. You can sign up for our courses and access our platform directly from the NMIS website, where you can also find details of other opportunities available through the Skills Academy and the wider NMIS group. I'll also post a link in the chat for anyone that wants to sign up for our learning platform. And finally, here's our small but growing team here at the MSA. Please feel free to get in touch and see how we can help. And without further ado, I'll pass you on to David, who will deliver the main body of our session today.
Right, thank you, Gregor. Let's start sharing. So hopefully you can all see that.
Yep, that's fine.
It's usual. Moving around the screen to Microsoft Teams is great, but at the same time, the only person I'm looking at is Gregor, which is quite intimidating for me. So, right. Anyway, a very good afternoon. As mentioned, my name is David Butler. I lead the Low Carbon Challenge Fund Extend project, which is funded for the similar sources as the Advanced Manufacturing Challenge Fund. These projects are aimed at SMEs in Scotland, and we provide free support to help them on their carbon journeys. So that includes things like doing an energy audit and also recommendations, and it can also involve a life cycle assessment, which is what we'll be discussing today. So all this is just to help companies know where they are, where they want to get to, because as I'm going to cover today a bit about net zero, it is a very topical subject, but also very vague. My co-presenter is Lee Patterson. At the moment, I think Lee's got a camera off. She's not had 100% health today after contracting, I think, some kind of viral infection. So we've tweaked it a bit. So apologies if you don't see Lee's face. She will come on when the time's right, and if not, she'll scream at me and tell me to cover her slides. So the idea is really to cover a fair bit, looking at recapping. So as Gregor mentioned, this is the third webinar. The first one was in April, the second one in May, and they're all 4 weeks apart. And that also means that some people may not have attended the previous two. So it would be good to, first of all, recap about net zero and the circular economy before going into what is a life cycle assessment. Why should we bother doing it? I mean, is it any use? I mean, does it help us out as a company, as any organization, to know where we are? Is it just another metric which is meaningless? So this is something which we will discuss before showing how it's used and going through case studies, in particular shopping bags. It's something we all understand, and there's a very good case study put together by UK government on the various shopping bags, which is the one we should have. Is the paper bag really that good, for example? We'll then signpost you some of the software programs available, as well as what else is available. And I think Gregor has already explained that NMIS is here to support companies on their journey, and they can tap in through NMIS into a wide range of other capabilities within an organization which is rapidly growing. So a recap on net zero. It's got different names. It refers to, you can call net zero really means carbon net zero, or more specifically, we're talking about carbon dioxide. It's become the easy metric to use. It's not the best metric, but like anything, we need a base level to compare to, and carbon dioxide seems to capture people's attention. It is not really just carbon dioxide, as I put in the second point. It's more concerned with all greenhouse gases. But we just seem to have this obsession with politicians to refer to it as carbon. It just makes it easier. If we are talking about what net zero is, it's really the balance between the amount of greenhouse gases which are released and those removed from the atmosphere. Where possible, you're trying to get it down to zero. And that's easier said than done. In most cases, we produce more carbon than we actually take out of the atmosphere. So it's how you move on that journey from our current status to something which is going to achieve that balance. All right. And the greenhouse gas, just by definition, it's one which aids or causes the greenhouse effect. That doesn't really help much, does it? That just repeats it, the same sentence, in another way. But it's really gases which get trapped in the atmosphere and lead to increasing the heat of the planet. So hence why we refer to it as the greenhouse. Not all gases up there have this effect, and they are not all the same. So methane, nitrous oxide, fluorinated gases can have a bigger impact than carbon dioxide. So in the previous webinars, we went into detail showing how we actually compare the output from methane in relation to how many units of carbon dioxide. How does it come together as net zero? Well, sorry, I've just jumped ahead one. Okay, beg your pardon. How does it come together as net zero? Well, we know carbon dioxide is used as the measure, and it's what we call the global warming potential. So it's a way to quantify each gas against that. So that is our baseline, and we see if it's worse or better. We can't really talk about carbon dioxide by itself as a metric. We actually call it CO2e, which is a carbon dioxide equivalent. So it's like we talk about distances in meters or miles. We talk about greenhouse gases based on a carbon dioxide equivalent. So that is our base unit. So you'll see this mentioned a lot as we go through the life cycle assessment later on. This is the way we measure. This is where you see the numbers and units, how many kilograms, how many tons applied to it would all be equivalent to CO2e. So that's how we use as a metric to relate one process and compare it to another. So this is a very quick recap. Like I said, there's a whole webinar on net zero, which goes into a lot more detail, but I'm very conscious as people on the call who've gone through this before. So it's almost like a rapid overview of where we are with that. If we're looking at recapping the circular economy, it's got many different definitions if you look through the literature of what is considered circular. So I'll take you through the comparison in a while between linear and circular. Really, the most common theme is how do we change? We have to change our current way of doing things to reduce the impact on the environment. And with globalization, it has meant as an accelerated depletion on natural resources. You look at Africa, for example. In the past, just a few countries were going in there to exploit the minerals. Now it's become a global rush, which is not ideal, but we do have to accept that many resources have a limited availability, and just keep on constantly using them and not thinking about how to reuse them is actually going to end up causing a lot of problems in the near future. So if we consider that a product is typically manufactured from virgin materials, which are probably mined or extracted from oil, for example, used by the consumer, and at the end they are disposed of, we can talk about a lot of wastes attached to that. If it's circular economy, we're trying to take that product at the end of its life and find a new use for it rather than dispose. And that is easier said than done. A lot of my activities personally are looking at the end of life of aircraft. How do we take the parts which are normally shredded and incinerated to create energy? How can we take those and repurpose them and find a new life for them at the end? Simple things are the seats in planes. That's a real challenge. Normally they're shredded. Can we look at a way? And nobody really wants economy class seats in their home. Business class seats or first class seats, yes, those are really nice. But there's 300 economy class seats on each aircraft. How can we make that a circular? So there are practical examples which NMIS and Strathclyde are working on. So if I look at the typical linear economy, which is our traditional way, we take, we make, we use, and at the end we dispose and we have waste. Now, as you can see, when we take and extract, there's energy and materials. When we make it, there's also waste. And all the inputs along this are going to be fossil fuels. Now, as we switch to renewable energy sources, that can probably mitigate the bottom line of this chart, but it doesn't detract from the point of view that we are still producing waste at every stage, and that's not sustainable. So just using green hydrogen or renewable energy sources does not get rid of the fact that we're still producing waste at the end. We need to think more carefully. So the linear economy has been what the established economy for a long time. There's now a lot of interest in the circular economy. And this is a chart which comes from a book called Cradle to Cradle. It's been adapted by the Ellen MacArthur Foundation, which is one of those big organizations which is actually out there delivering both training but also promoting a sustainable future. And this is known as the butterfly diagram. If we look at the right-hand side first, we got the classic, finite materials are extracted, we make parts or products, and we have the service. And out at the end, ideally, in the old ways, we just waste it and goes into landfill. Now, if you notice, we've got all these circular loops of how we can share products rather than just have it for ourselves. Can we make better utilization of it? So rather than buying 10 cars, and cars typically only used less than 7% of by the owners, maybe we have 10 people sharing a car, so we use less resources but maximize it. Or we can look at extending the life of products. One of the things we're doing in Scotland at the moment is wind turbines. 770 wind turbines are coming to the end of their useful life this year and next year. How do we extend their life and get better value, and rather than trying to dispose of it? So it's things like that. We can also look at reuse and redistribution. I gave the example of the aircraft. We ideally would like to find a reuse for those parts rather than disposing of them. And we also have the option of refurbish and remanufacturing. This is very well established in some industries, something which a lot of people have done without realizing, well, probably don't associate with remanufacturing, is printer cartridges. There's a massive industry in Europe taking the printer cartridges, particularly the inkjet cartridges, and remanufacturing them, taking them apart, replacing the ink, and selling them at a reduced price compared to brand new. And it's also automotive has been one of the leading industry sectors for remanufacturing. A sector which also does it, which doesn't use the term, is the aerospace sector. When you fly in an aircraft, you're buying an air ticket, you're paying for the service. What you probably don't realize is that the engines on the aircraft have gone through a lot of refurbishment. Parts which have got blades which have been damaged over the years have been replaced with new ones or repaired. So we do have remanufacturing on a lot of parts. Ideally, these are the things we want to do. The one thing we try not to do, if possible, is recycle. The worst is landfill. Recycle is next, where you're taking a lot of embedded energy and you're cutting it down, shredding it to create feedstock, not very desirable. So this is our typical, the options we have available. On the left-hand side is more to do with the biological side, where we have biochemical feedstock, where we extract, we can produce biogases, and we can look at even things like farming, how to make better use of what comes out from the biological cycle. So 2 cycles on the same diagram, hence we call it the butterfly diagram. But it is the foundation, see all the terms there which we use: recycle, refurbish, remanufacture, reuse, and share. So that's just a quick recap on the circular economy. So you can see for many industries, many applications, it's a mind shift change from what we currently do, which is maybe selling a product, to moving towards selling a service. The servitization model is the way to go forward, and therefore we don't ever sell the product. We own it, we maintain it, and we have a business model which allows for continuous cash flow, as companies will pay to do it. So we've seen examples already with cars, share pools of cars. There's quite a few companies doing that. Around Glasgow, for example, you've got the bicycles. You can share the bicycle by renting time on it. So it's already a well-established model. It's how far it can go into other sectors, and that's the challenge, developing the business case to do that. And that is partly what the Extend project is helping companies do. So what is LCA? Lee, are you ready?
Yeah, I'm good.
Okay.
Yeah, so apologies that my camera is off, but I'm not particularly well today, so doing quite well to just be here and talk, I'm afraid, so you'll have to just listen to the voice. So what is LCA? Essentially it would be called life cycle assessment or analysis. You'll maybe hear both. They're relatively interchangeable. And it's a systematic technique to try and determine the environmental impact across the life stages. So what David just showed you with the linear and circular economy, those are essentially life stages of a product or service. So the linear economy is a cradle to grave. So you start at the start and you end with landfill. The product doesn't exist anymore, so that's why it's known as cradle to grave. Whereas the circular economy, because it should hopefully be going round and round, that's where cradle to cradle comes from, that you reach the end and you go back to the start. So that's essentially what the life stages, the life cycles of a product are, and the stages are the individual parts between that. So an LCA should include a full assessment of each stage, so raw material extraction, manufacture, transportation, use phase, and everything in between. And it should also include all upstream and downstream aspects. So David will get into this a little bit later with looking at scope 1, scope 2, scope 3. And this extends also to all the appropriate inputs and outputs. So, for example, if you're looking at the electricity that you need, the pollution that's emitted, all of that should be accounted for within your assessment. It's used for a whole host of different things. So you can assess design options. You can use it essentially to put in a product. You might have multiple options for products, different materials that you might want to choose, and you can determine which is more or less environmentally impactful using LCA. You can also do it to help produce like carbon reports if they're required, as some industries are bringing in, and also it helps to set benchmarks. So how can you change for the better if you don't know where you sit at? So it's always a good thing to have that starting number. There's a number of programs and databases which you can run on. David will explain those towards the end. But you can also use different kind of categories for this. So as David touched on with the net zero recap, you can be looking at global warming potential, so using CO2e as your marker. But also you can look at things such as toxicity. So I'll get into those as we get further on. But as an introduction, you can see it's a somewhat complex model. So we'll try and break it down as we go along. Next slide, please. So why is it important? And a number of you will have seen these slides from the last ones. They're very much the same. Why is it important to measure your climate impact? So I mean, it's fairly well established that human activity is having an impact on climate change and warming. So being able to measure that, both the change and the ways in which we're impacting it, obviously is extremely helpful for making any positive changes. Next slide, please. As well as governmental policies coming in, so I'm sure everyone here is familiar with having the Paris Agreement set in place. We also have the COP26 agreements that were put in place to try and set net zero targets. Again, in order to set net zero targets, you need to have a benchmark and you need to have a way of measuring what you're doing. So that's where LCA comes in. Next slide, please. Perfect. So global net zero targets. This is just an example. You can see there's 2 countries achieved their net zero targets and a number which have set quite ambitious targets for the end of this decade. The UK up towards 2050, Scotland of course set it for 2045, and then you've got the larger deadlines such as China with 2060 and India 2070. But you can see that it's being well established across the globe. So it's definitely something that whether we like it or not, you're going to have to pay attention to it. Next slide, please. So just to go into further detail, again, I'm sure you've kind of heard about some of these between the last programs or the news, but in order to achieve neutrality, clean transportation and energy production are kind of the key enablers that we've kind of tapped onto at the moment. So with the ban coming in for new diesel or petrol cars, hybrid as well, 5 years later, and as well as setting targets here in the UK for how much renewable energy can power the country, it's definitely something that's coming in, and it's coming in quite fast. There's also the Fly Zero initiative, which is looking at aircraft, which David kind of touched on. So it's not just sticking within cars and energy, it's definitely going beyond the scope. So we envisage that it will go across multiple more industries quite quickly. Next slide, please. So the common theme across all of these is, of course, as I mentioned, the measuring. So we need to be able to measure your climate change, carbon emissions, pollutants, and so on in order to really account for those changes. And this is where LCA comes in. We can't measure, well, LCA is a very effective way of measuring. And so this is why it's quite important to get our heads around it. Next slide, please. And I believe I'm passing it back to you.
You're passing it back to me. So, what can it be used for? So I'm going to give a case study, but first I want to just mention one of the terms which we hear, which is carbon accounting. And as put down there, it can vary in definition. It's nice being accountants. We know how to do finance. Why can't we do the same for our carbon equivalent? So really, it starts off with there's a lot of calculators out there. You can work out your carbon footprint. So the process can be used for individuals or organizations, and it's always quite depressing if you fly a lot and you suddenly see what your CO2 equivalent footprint is. At the same time as putting it down in terms of carbon footprint, it's also the ability to actually put money value to it, so monetary value. So, for example, we have carbon offsets, which work out at the moment something like £1 per ton of carbon dioxide equivalent, and you can quickly use that to work out a baseline, and that's going to go up in price as we go forward. So, we talk about this carbon footprint. Really, life cycle assessment, LCA, is the thorough method of assessing that, because there's so many factors. The more you think about it, the more depressed you may get when you realize how many things come into play when we're looking at it. And hopefully some of the case studies will explain that. Across the globe in the last few years, it's become quite mandatory. So at least at the moment, 40 countries, probably now more by now, have said it's important for companies to report on their carbon. And at the same time, there's also activities to try to standardize it. So we haven't got international standards as such, but there's no ISO standards as per se, but there are organizations which are establishing benchmarks which the multinationals are adhering to, and that becomes part of the credibility. So there are acceptable standards which will eventually become enshrined in law around the world. So one of the best ways to talk about LCA, not the calculation part, but just the thought process, is to go through a case study. So I did this fictitious case study, which I presented at the previous webinar, so I'm going to go through it again. Imagine you've got two car companies. The first one is the Eagle Car Company. They build beautiful red cars. Engines are diesel or petrol. You've got two options. But as a company, they realize they need to have a net zero plan. So this is their starting point. We need to have a net zero plan. So they looked at the factory, and the factory takes in the metal, forges it, bashes it around, and out comes the end of the production line, comes your nice shining red car. So they looked at the carbon emissions from this facility and decided we need to do something to reduce it. So the first thing to do is change the energy source, because solar panels, we can use that to say that we are doing something environmentally friendly, and that's going to reduce their carbon emissions, their carbon footprint. They also go, well, that's great, but some of our processes or forging, we've got energy coming in, clean energy from our solar panels, but we're still not going to balance it out unless we look at a carbon offset. And this is where they plant trees. Now, planting trees sounds a great idea. The challenge is you don't immediately get the value of planting trees. It takes 15 to 20 years for some species to get to a size where they actually are taking in a sufficient amount of carbon dioxide to make it worthwhile. But to all intents and purposes, we are now saying that this factory is net zero because we've managed to offset all our carbon. Now that's a bit misleading, as you'll see on the next slide. We produce the cars, out they go on the road, remember it's diesel or petrol, and during the lifetime of the car, really our carbon emissions from what we're doing only makes up 5%, because the car is going to burn fossil fuels. It's also going to need parts replaced over time. Are we sure those are actually sourced from environmentally friendly or organizations which have a net zero target as well? So it's very much looking at it through through blinkers. We're only looking at a small part of the bigger life cycle of the car. So while we're claiming as a company to be net zero, it wouldn't stand up to any international comparisons, and our credibility would be at risk. So we need to rethink it. So that's the Eagle Car Company. Now, cars are quite nice, very retro. Now, the Osprey Car Company looks a lot more impressive. Now, this company, the car is is a petrol engine, but they are looking at moving forward to electric vehicles. So as it stands, it's a petrol-driven vehicle. And we've got the same issue. We've got a similar factory, so we need to think about how to reduce energy bills. We first of all put on the solar panels to try to focus on our emissions. And this is where we now define it as scope 1, direct emissions from our process. And how can we try to reduce those? But, you know, we're still not looking at the bigger picture. The first company was very focused. We now, when we look at our life cycle assessment, we need to consider secondary emissions, or scope 2. And this is where scope 2 is where our energy source comes from. Is it a clean energy source? Our heating and steam, can we with confidence say it's not from burning fossil fuels? So we're now extending our assessment beyond our own factory into our energy sources. Where's it coming from? And this is still not exactly there. We still got the next part, which is, well, although we in the factory are saying we've neutralized our emissions, we're now net zero, we're not too sure where some of our parts come from. And this is where the term greenwashing is used a lot. So say, for example, I get parts from the other side of the world. When they arrive in Scotland, I can say they got 0 carbon emissions because I don't consider the mining, the manufacturing, or the shipping around the world to Scotland. You know, if I'm doing that, then I'm really not telling the full story. We have the same issue here. Our car is typically made of around 12 to 18,000 parts. These are indirect emissions. Are these parts, the plastics, is it made from a sustainable source? Is it recycled plastics? Are the tires actually made from the right material? Is that also, is it natural or is it artificial? How's the process to making that? And of course, the material, the metal in particular, how it's being mined. The first one, which I skipped over, was the emissions. We know from the previous example, right, through the life of the car, there's also the emissions. So we now need to consider that. How, so it's getting more complicated. It doesn't bode very well for an automotive manufacturer now producing diesel cars or petrol cars to say they can be net zero. You've got to permeate it through the supply chain, which is quite a challenge. So this company's putting a hand up and saying, we're not going to do it. We can't really claim to be net zero throughout our current supply chain, but have a net zero plan, which is increased use of recycled materials. So they're going to move towards it. And this is something which is quite important. It's very rare. It does happen, but very rare for many companies, particularly manufacturing, to do it overnight. You're looking at estimates, an AS who's on the call estimates it takes between 5 and 6 years for a company to, you know, to start on a journey and to get to somewhere where they can consider themselves net zero. The bigger the company, the more challenge it is. So apart from increased use of recycled materials, maybe I can switch to electric vehicles and stop using petrol, and that help, maybe will also help me towards being a truly net zero company. And these are the kind of factors we have to consider. Now, our net zero plan now is, this is our current way, you know, as it is, but we need to put pressure on our supply chain. So we need to move from normal material providers to actually auditing our feedstock, our companies. So you can see here, we've got recycled aluminium, for example, which is one of the best materials. It's of all the metals, aluminium is the most attractive because the amount of energy used to recycle it is very low. So we're going to make our cars out of recycled aluminium. That's a real plus point. And as we force our supply chain to go greener. And why can we do this? Because as OEM, we have a supply chain which relies on us for jobs. It's logical that we can help them and they can help us. So we help to put them on the journey. And if they don't, we change suppliers. There is parallels to this from the 1990s and 2000s with ISO 9000, where if the OEM gets ISO 9000, they actually pushed it through their supply chain to ensure every company also adopted ISO 9000, which is the quality standard, so they could ensure the quality throughout the process. And we've seen the same happening with net zero. Now, how does it work? It's really like, I guess, you know, one company tells The Osprey tells their tier 1, they tell their tier 2, and eventually it goes through the whole supply chain. And then you really see the impact of net zero in a particular product. So that is a bit of an example. So you can see how we can play very carefully. The first company claimed to be net zero, but really only focused on a very limited part of the story. The second company, Osprey, looked at the whole range, which takes a lot longer, but if you really want to make an impact, that's what they have to do. So passing on to Lee now.
Yes, hello, I'm back. So we're going to go, we're going to discuss how do you use it. If we could change slide, please. So essentially, it's a very complicated and time-consuming process when done correctly, and I won't pretend to be an expert on it. But it is something that it's important to set it up for success and to try and get it done correctly. There are 4 stages to aid with this. So the first is goal and scope, the second is inventory, the third impact assessment, and the fourth interpretation and improvement. So I'll just quickly go through each one of these to try and introduce you to the process flow that you would do when looking at doing an LCA. So firstly, goal and scope. So the first step, of course, is to define what exactly you need to analyze. So there is some ISO 14040 standards there, which kind of outline this for you. But they can include things like what are the intended application, what is the purpose of the assessment that you're carrying out, what system is being assessed in its boundaries. We'll come on to that in the next slide. And what is the intended audience. So the idea of this is really for you to nail down exactly what you're looking for from carrying out your LCA. As I said, there's a whole host of terminologies, so I'll get onto that in the next slide. So firstly, it's a good idea to set out what the function is. So what is the use of the product or service that's being assessed? I've put in green here some examples. You'll see in the bottom right, there's a link. This was a LCA carried out of a supermarket carrier bag, which David will run through a bit more later on. But just to kind of help explain what each of these terminologies are. So a shopping bag would have the function, obviously, to carry shopping. Fairly simple, but the complexity of what you'll put in function will be relative to the complexity of your product or service for that matter. The functional unit is where you try to be as specific as possible. So you're looking at what exactly it is that you're trying to assess. So for the example here, we're using to carry 1 month's shopping, which is 483 items from the supermarket to home in the year 2006-2007 in the UK. Again, this is taken directly from the UK Environmental Agency example. So you can see that they've went into a very specific number there. And also it relates to the function. So the function is to carry shopping, and this is telling you what specifically you're looking to carry over that time. It should be quantifiable, so that's why we've got 1 month and a number, although I would argue that 1 month is somewhat questionable, 30 days maybe. But again, it should be quantifiable and clear to define, clearly defined. The product system is basically the product life cycle. So as I kind of mentioned before, if it's cradle to grave, a linear process, or cradle to cradle, a circular process, that is essentially the system that you're looking to take on. And the system boundary is determining which aspect of the life cycle that you're going to include in the study. So you could do the entire cradle to grave or cradle to cradle, but it may be that actually you're looking to focus on only one specific area, such as manufacture, or cradle to gate, which is where you're looking at it from raw material extraction up to the point where it leaves the factory door to be sold for service. So there's a few different ways of looking at system boundaries, and it really depends on what you're looking to carry out. So this list of things is something that's really good to nail down at the start, so that you can really use the tool to the best advantage for yourself. Next slide, please. So this again is taken direct from the UK Environmental Agency. This is what they put through. So you can see quite a complicated flow diagram looking at the extraction of the product all the way through to the use and end of life stages. Apologies if it's a little bit hard to see on the screen, but essentially it follows left to right and then doubles back on itself. The system boundary you can see is highlighted with a box around the whole system. This is because they were looking at doing the cradle to grave of a carrier bag. However, if we can move to the next slide, I've put a more simplified version for you. So you've got raw material extraction, material processing, component manufacture, assembly, use, end of life. I've also got transportation and packaging in there. So the box on all the way around is your product system. So you can see it encapsulates every aspect of the process, as well as energy emissions and so on. Whereas the system boundary perhaps is only looking at very small amount of, so this, in this example, you're looking at a cradle to gate approach. But again, if you wanted to only look at one aspect, you could pull your system boundary down. Next slide, please. So moving on to the inventory, this is the second stage. The life cycle inventory you may hear referred to as LCI. So essentially, this is fairly straightforward. You require an inventory of data in order to carry out an assessment. I think that's fairly self-explanatory, but the difference is where you manage to get that data from and how you're able to collect that data. So there are existing databases which are available to use either free of charge or by purchasing, and David will talk through some of those at the end. But addition to that, you're probably going to have to collect some of the data yourself, looking at your suppliers or looking at a certain aspect of the manufacturer. You may have to go to your direct suppliers there. So it's something to consider is how you're able to collect enough data for you to carry it out correctly. It should account for every input and output. So if you look at one of these, it's actually quite scary because some examples have hundreds of inputs and hundreds of outputs, including all the raw materials, which includes waters, chemicals, gases, different energies that it may take either from grids, renewables, perhaps it has solar panels on the roof, so you have to have all of those in, and emissions. So your emissions are not just pollutants, but they're also anything that emits into the environment, so your water, your land. And so this is the kind of depth of information that you're really looking to get to form your inventory. It's not to be underestimated. It is very complex and it's very, very difficult to get that information. But it's something that you must consider at this stage. Next slide, please. So other considerations that you may have at inventory is, as I kind of said, where the data is going to be collected from. The quality and accuracy is quite important. So can you verify that data? Are you sure that the person or the organization that you're getting the data from is correct or validated? And is it exact? Is it an assumption or is it something in between? So to have that knowledge and really to make sure that you've stated whether it's based on an assumption or based on an average and so on is also quite important. It's quite often demonstrated the inventory stage through a flow model diagram. This is just to really help keep track of what you're looking at. So for example, here you can see that 2 raw materials go through processing before assembly, whereas perhaps a third one comes in direct. This is a good way of keeping on top of the fact that whilst you've got one product, you've got 3 raw materials that you need to get data for. So it's always advised to do a flow model at the start. Next slide, please. So moving on to step 3, this is the one where you're actually carrying out the assessment. And it's essentially the combination of looking at all the data that you've collected at the inventory stage in order to then produce your results. Now, there's a lot of different categories that you can produce these under, and they can be displayed with. So, for example, there's the example here is that you could use the measurement of kilograms per CO2 equivalency to assess climate impact. You can also use GWP, but it also different categories will look at different aspects as well. So human, terrestrial, aquatic toxicity. Does it impact the ozone? Is there acidification produced from it? So again, there's a number of categories to pick from. It's not particularly easy to work out which one to select. So it's something that at this stage you need to take the time and find which one is the most appropriate for your business, for your product or your service, and which factors to include. So do you need to look at toxicity? Is there toxicity? Is it something that maybe you hadn't considered before and actually it's quite high now? So it's definitely something you want to keep on your radar, and so on and so forth. So at this stage, you'll be carrying out the actual assessment, and then presenting those results essentially through the categories. Next slide, please. So the fourth and final stage is your interpretation improvement. So interpretation is essentially where you try to identify any key issues. So depending on what categories you selected, it could be that you find that one component has a greater environmental impact based on GWP than another, and that's something that you'd like to focus on to try and bring that down. That should therefore open the door to discussions on how can we make changes in the process to reduce the environmental impact, and essentially to try and bring it down for that individual component, for example. And it also, at the interpretation stages, you will get a report essentially of your results, and that should be put into any reporting or mandatory reporting that you require. And to loop it back to the goal and scope, what you've set out, that's what you're looking to get at this interpretation stage. So what the government were looking to do, the environmental agency were looking to do, was to find out how much impact there was on warming of the carrying of 483 items over a month. So the report that they've produced and the categories that they selected should give them that result. The interpretation phase should also check for completeness, correctness, quality. So there's a lot of ways of perhaps doing this incorrectly, not deliberately or deliberately, but there's a lot of ways of making errors along the way. So it's a good point here to really go back through your data, make sure that what you've put in and the data that you've collected is accurate. Basically, that you've done your due diligence for your reporting. Next slide, please. So yes, I'm sorry, that was a bit of a whistle stop of how to use it, but the 4 stages are very well documented. And as I said, you can refer to ISO 14040 to look through those. And yeah, hopefully that's given you a bit of a flavour of the complexity of this process. So it's not something to take on board lightly. I'll pass over to David to talk more through about the shopping bags. Right.
So as Lee mentioned, there's a good case for the shopping bags. Just to, as a team, we've actually carried out a life cycle assessment on wind turbines. Bit of a bigger example than this one, but to really look at the options at the end of life. Do you repower the wind turbine? Do you strip it, leave it alone, or do you demolish it? Leaving it alone may sound good, but over its life cycle, as it gets older, there is issues regarding its performance and replacement of parts. So what may seem the logical option when it comes to net zero, we actually went through the whole analysis and recommended to a company, based on their life cycle assessment of their wind turbines, which option they should go with. So taking it to something a bit more mundane, but as Lee said, it's very common. We all know shopping bags. I thought it'd be good just to spend a bit of time looking at summarizing the reports there. The details all there. It's a brilliant report because it goes into a lot of details on all the assumptions made, and they tested 8 different bags with high density polyethylene or with low density, and then in between you've got things like non-woven polypropylene bags, paper bags, cotton bags, and even starch polyester. So I'm not going to go through all the examples, but you would tend to think certain bags make more sense than others. So if you think a paper bag sounds like a good environmentally friendly option because we know paper is from a sustainable source. So let's have a look at the life cycle assessment for paper. And if you look at the text first and look at the diagram on the right hand side, we can see the extraction of raw materials. We need the paper, no surprise. And these numbers are for so many bags. So there's a volume of bags involved. We need glue. And when you actually distribute bags to the shopping centre, to the supermarkets, they actually package them. So you actually have secondary packaging, which can be using film to wrap them in and to keep them dry, and also them stored in a cardboard box. So straight away, you can see we've got 4 blue inputs into this. Transporting the bags, we're using a 16 to 32 ton lorry, and it worked over a distance of 1,200 kilometers. Also has a certain amount of carbon footprint attached to it. And going to the supermarket, separating it out, what goes to waste, what gets incinerated, which is a very small amount. A lot of paper bags actually go to landfill. So what seems like a nice environmentally friendly option is suddenly looking not so good. Where possible, certain things like recycling the card will take place, and some of the core board may not be recycled or actually reused. So try to avoid doing anything with it, maybe repurpose it. What this tells you is, if you read the left-hand side, is a paper bag is used 4 or more times. It needs to be used more times to match up with a simple plastic bag. So the conventional high-density polyethylene bag actually looks quite impressive compared to paper. And we also find the way paper is produced, a lot of chemicals are involved. There's a lot of places where the chemicals are discharged into the water, so the ecotoxicity is quite high. And I think the last quote is very important. It's unlikely the paper bag can be regularly reused. They do wear out. They're not for a lifetime of more than 3 or 4 uses, I guess, before the paper gets weak. So really, a paper bag doesn't come across as being an ideal product. So HDPE, high density polyethylene, seems to be more attractive. And here you got the example. This is the conventional one. Because it's using polymers, it's a bit more complicated, the flow charts than what we had before. As you can see, we've got metals coming in. So we've got chalk and titanium oxide, which is part of the process, and we've got our polymers. All this has to be transported, and in this case, the bags are made in China, which then means that we shipped from the factory to the port, and then it's 15,000 kilometers to the UK. Once arrived at the UK by train to a distribution center, and the last 200 kilometers is from the distribution center to the supermarket. So there's a massive transportation part in this because economies of scale dictates that plastic bags are made in only a few locations. We also note about the secondary packaging. It's always funny to think that a plastic bag is packed in a plastic bag, but that is the case. And we can clearly see, even at the supermarket, how much goes to waste. 86% goes to landfill. But this is still seen better than the paper bag. It has the lowest environmental impact of all the bags. So 8 of the 9 impacts. So what looks quite depressing, actually, surprisingly, it's probably the best of a bad bunch. And one of its advantages is it's light. So the carbon footprint for transportation for one plastic bag is much less than a paper bag. So a bit of it is, not as simple as it sounds. It's not the actual process of making it. A lot of the footprint is attached to transportation. And of course, the lighter it is, the lower the footprint from that. And it puts down here the life cycle impact of the bag. Really, it was raw material extraction and the production, which uses a Chinese grid. Most of the Chinese national grid is still using coal-powered fire stations. So the source of the energy is not ideal as well. And also because it's producing sulfur dioxide, acid rain, we do have that taken into consideration. So if this was made in the UK, if we could, maybe it would be slightly more manageable. Distances would be less, and hopefully our electricity sources are a bit greener. But this is globalization. So surely cotton should be better. I mean, cotton bags, we give them, you go to conferences, exhibitions, they like to give you cotton bags because they're seen as longer lasting. It's quite shocking because the production of cotton is very chemical and water intense. And you can see from the diagram, we've got the cotton woven and the cotton thread, and both these are transported. Yet again, in this case, the bags are made in China, so we got the same impact due to electricity, and it transported the same again to the UK. Interesting to see, it's still the same. Most of the bags end up in landfill. What makes this very unattractive is really the way the cotton's produced, and to justify or they've been in the calculations, you have to use it at least 173 times just to make it slightly respectable, because there's so much locked in ecotoxicity, chemical usage, and energy from the actual growing of the producing the cotton in the first place. So it's a very simplistic look, but it's just to show you that when you start analyzing things, it's the supply chain, how it's disposed of, and how the initial material is extracted. So what programs are available? This is really software we're talking about. So there are a lot of software, some of it's free of charge. So it's open source. OpenLCA can be downloaded. It takes a bit of time, like all these, as Lee showed. There is a lot of effort needed to actually learn and understand what needs to be included. So there is tutorials, but it's still a lot of work. OpenLCA is one of the software we use in Strathclyde. The other one is Simmer Pro. Somebody on the call today and is our specialist in that. And there are a few other softwares. There's probably more than this, but these are the four the most popular. The thing which makes them important and helps standardize it is the database information. So typically a company called EcoInvent has a database which a lot of these software extract from, and that actually has a licensing cost. So while OpenLCA can be free of charge, to access the databases does come with a cost. And those databases are constantly updated, but it does provide a standard across all the different packages. So really the packages become more of the interface, and the brains, the data is stored in this case in EcoInvent. So really what help is available? I've just put down we got NMIS, of course. So as we mentioned earlier, Gregor has explained there's a lot of resources available in NMIS, but there are other organizations as well. We have Zero Waste Scotland, and then we have organizations like the Science Based Targets, which try to put a bit more structure and I guess confidence to some of the calculations. And these are what industry would say we are following science-based-targets.org to show some credibility with how they calculate their carbon footprint. We've got the Carbon Trust. The Climate Change Committee for the UK provides a lot of information, and UK Gov has a very simple carbon calculator, but it's a good first principles and first start to understand what is the carbon footprint. And then you've got other software there as well. So hopefully, I mean, we kept to just in time for 3 o'clock for the lecture part, for the talk part, sorry, not lecture, it's a seminar or webinar. Hopefully that's given you an overview of the life cycle assessment. It is something we do as part of our engagement of companies. It is not a 5-minute exercise, and typically, the first pass of doing an LCA doesn't provide you all the information. It's only through understanding what you get and where the gaps are, do you get towards something where you can say, this is our current status as an organization, and then you can actually start talking about where do you want to move to in year 1, 2, 3, and maybe achieve net zero in 5 to 7 years. Okay, that's it. Thank you very much.
Thanks, David, and thanks, Lee, for your efforts again today. Really interesting session again. As I could see in the background there, the chat box was buzzing away, and there's been lots of good dialogue going on there. And thanks, NMIS, for picking up some of those questions as well for us. Abdul, I know you've been keeping an eye on the chat there. Is there any questions that we still need to have answered by the panel?
Thank you very much, Greg, and also just another thank you to David and Lee for this beautiful presentation. I'll just run very quickly through the questions. I know we're kind of running out of time, but one of the attendees asked that they missed the first 2 webinars on the introduction to circular economy and introduction to net zero. These were the 2 webinars as part of the 3-part series, and they wanted to know how would they get access to this. And Laura was kind enough to answer the question. You'll find, just to repeat, you'll find all our recordings on our YouTube channel, and we can provide a link to that after the webinar. Another question was if it was possible to get a materials list for the wind turbines so that the new uses can be considered, and Lee was kind enough to answer that. And the answer was there are many hundreds of components within wind turbines. There will be bill of materials, perhaps not for the entire turbine, but sub-assemblies. Lee mentioned also to send us an email after the session, and we can have a look for anything open source. There was also another post answer to that from NES. If your goal is to conduct an LCA for the wind turbines, don't forget that you can use the 1% rule. The only components that weigh more than 1% of the total weight are taken into consideration, or 1% of the total emission. This could limit a little the number of components. A follow-up question to NES's answer was, what if the individual component weighs a fraction of 1%, but there are hundreds of the same component? Do you use the sum or ignore them due to the individual weight? And NES was kind enough to answer by saying it depends on what your system boundaries are, but typically yes. You can input the number of components needed, for example, 100 washers, and based on the total weight and impact, if the sum is more than 1%, then you could take that into consideration. David and Lee, do you want to say anything more to that?
No, I mean, we carried out a project last year on this, so we do have some information which I need to check, because we did do it with a company. If Chrissy drops the email, we can probably share it, some of it, and see if that helps as well. We do have a knowledge transfer partnership just started with a company to look at what else can be life extended in wind turbines. Currently, it's mainly just a few parts, like the yaw gears, but one of the reasons why we need to look at end of life is that the approximately 1% performance drop each year in wind turbines. So over a period of 20 years, it's dropping a fair bit. So how do we get it back up? So more than happy to have a chat with Chrissy about that.
Thank you. Another question was, perhaps before you touched on some of the other later topics, David and Lee, but will this webinar address LCA for food processing? And Lee was kind enough to answer, not specifically, but it introduced how to conduct an LCA, which is applicable to food processing also. Another question was, would you be able to share the slides at the end of the webinar? And our answer is the same as before. You will find all our recordings on our YouTube channel, and Laura was kind enough to share that link earlier, but we will happily share that link with you post webinar. Another question was, is there any specific tool software application that you would recommend for LCA, or would a simple spreadsheet be just as good to go through? Lee will answer that. There are a number of tools and software which were later presented post the question. And is there anything else that you want to add to that, David or Lee?
I think NMIS has also put a link, hasn't he, to EnvironDeck or something, which is, I think that's another piece of software as well, which I haven't come across before, so I defer to NMIS on that.
Perfect. And I think NES also answered to the next question I was going to read out, which is, the LCA process is still new for most companies. How do we know what a good figure would be? Are there any examples available for benchmarking? And that's when NES kind enough was able to share the link, and where he also mentioned that this is a web link or a portal where you can input your product and obtain an idea of its impact. I believe that's all of the questions. Are there any other questions that I missed out?
Scott's put an interesting point in, and he's right. The example I went through was the thicker craft paper for the bag. And he's right, it could be opportunities to look at alternative paper sources, but the UK investigation was on a certain bag which was used in the current shops, but you're right. You mentioned about using recycled pulp paper. I've actually just finished a project on making leather out of oranges. So it is interesting how strong it can be. We made sounds really bad. We made a handbag out of orange peel. So yes, you're right. There's some very interesting stuff we can do with using the pulp from fruits to create new materials. So you're right. It is misleading. It was the timing of it, which was 2008, as I think Lee mentioned, or 2006. You bring up to date. I agree with you, Scott. There's a lot more we could do and go back and revisit.
Okay. I think we've just about captured everything there. So thanks everybody for joining us today. Thanks again to David and Lee and the team for helping give you the webinar today. And I think we can draw things to a close.
Thanks very much, Greg. And yes, just to say thanks very much to all our speakers today, to David, Lee, Greg, and also for Abdul for facilitating the Q&A session. And thanks everyone for joining us. And we'll just bring the webinar to a close. Thank you.